Hello, dears, and welcome to Al-Hussaini Virtual Lab Pathology Talks, Tips, and Practical Tips. What I'm going to be sharing with you today is a nice example of atypical choroid plexus papilloma. This is a case of an 11-year-old male patient who presented with headache and was found on investigation to have a fourth ventricular tumor. And as you can see here from the low power magnification, there is some vague papillary architecture. However, there are some other solid areas that are intermingling with the papillary architecture. On a slightly high power magnification, as you can see here, the papillary areas are composed of fibrovascular cores that are lined by cells, mono-layered cells with minimal pleomorphism, some apical cytoplasm, sometimes even forming what appears to be like a glands, and even on higher power magnification, a little bit in the way of a pleomorphism. The nuclei are somehow elongated. The fibrovascular cores are very clear. And then in some areas, you can see what looks like signet ring appearing cells. Now, in other areas, there is a clear solid growth pattern. So no longer the papillary architecture is clear, rather there is solid growth pattern with what appears sometimes to be like compressed papillae, but in other areas these are like a true solid growth pattern with some clearing of the cytoplasm. And on high power magnification, this appears to be like a widened papillae. Some remnants of papillae are seen here, and again the lining cells show some hyperchromasia, not much in the way of pleomorphism, and some what appear to be like signet ring cells. In other areas, completely solid growth pattern, again some hyperchromasia, not much in the way of pleomorphism, but then we started to see mitotic figures, and we counted mitoses. This is one mitosis, this is the second mitosis here, and the mitosis is in the range of 2 per 10 high power fields, which really, along with the architectural growth, would raise the possibility of atypical choroid plexus papilloma. So further into immunostain, the tumor cells were diffusely positive with pan-cytokeratin, one positive, also with S100 showing positivity both in nuclear and cytoplasmic, as well as synaptophysin. And this is the typical immunohistochemical staining pattern or a profile for choroid plexus tumors in general. Now, GFAP was focally positive in some of the tumor cells, not really widespread positivity. Unfortunately, at the time, we did not have transthyretin, which usually shows the cytoplasmic or even sometimes the apical positivity, which would support the diagnosis of choroid plexus tumors in general. Now, because of the age, because of the morphology, always remember to rule out germ cell tumors, especially in midline structures, and SALL4 is an excellent pan-germ cell tumor marker, and it's completely negative. This is important because of the management is completely different than between germ cell tumor and other types of central nervous system tumors, including choroid plexus tumors, so whether this is papilloma or atypical papilloma. P53 is important to do because of association of choroid plexus carcinomas, in particular with Lifromani syndrome. This is why we did the P53, and as you can see, there is some non-specific staining in the cytoplasm, but what is really important is the nuclear staining, which is kind of mosaic, and this is consistent with wild type staining pattern. For the Chi67, now, in addition to the mitosis that we have seen, atypical choroid plexus papillomas usually show slightly elevated Chi67 proliferative index in the range of 5 to 9 or 10%. This is around 5%, as you can see in the image. Now, furthermore, we did the DNA methylation profiling as well as copy number variation, and the diagnosis, this is our supplier diagnosis, our original diagnosis. Now, the diagnosis came back as choroid plexus tumor or choroid plexus papilloma adult type. Now, remember that in methylation profiling, the classifier does not provide a grading in choroid plexus tumors, so it cannot differentiate between the typical choroid plexus papilloma and the atypical choroid plexus papilloma, which remains really a diagnosis based on histological features. Now, interestingly, the copy number variation profile shows some very interesting trisomies, in particular gain of a chromosome, whole of a chromosome 5 as well as of a chromosome 9, in addition to other chromosomes. And why I have highlighted these two in particular, because in a recent publication that looked into a number of choroid plexus tumors, their methylation profiling and the copy number variation that is associated with these tumors, typically a trisomy 5 as well as a trisomy 9 are the ones that differentiate the adult subgroup of choroid plexus tumors from the pediatric A and pediatric B subgroups. So the final diagnosis in this case is atypical choroid plexus papilloma, CNS WHO grade 2. Remember that atypical choroid plexus papilloma is a diagnosis that is rendered on histology. This is based primarily on mitotic figures, the presence of 2 or more mitoses per 10 high power fields in the presence of other supportive features, including some solid growth patterns, some pleomorphism, even sometimes necrosis. One point to remember that brain invasion per se can be seen in papillomas, in atypical papillomas, or in choroid plexus carcinomas. They do not affect the grading of the tumor. So unlike, for example, meningiomas, the presence of a brain invasion would not really impact the grade of the tumor. Remember that with methylation profiling, the methylome can give support the diagnosis of a benign versus malignant choroid plexus tumors, but cannot really differentiate between a grade 1 or a grade 2, that is to say the papilloma versus the atypical papilloma. I hope you find this tip useful in your daily practice. Thank you.